Listen to part of a lecture in an astronomy class.
So, I hope you now have an idea about the most accepted theory of how the Sun and the solar system were formed. In fact, many new observations are showing major problems with this traditional view of planetary formation. For example, some scientists are now saying that the time frame is all wrong. The planets may have formed much more quickly than the standard theory suggests. And there are other problems too when it comes to the formation of the outer planets, especially about how and where they formed. Some people are saying we may have to revise or even abandon the standard model. As with many theories in science, it's pretty much open to revision. But now, let's move on to an examination of what happened inside the Earth in its early stages. I know some of you have studied Earth formation in other courses, but I want to fill in the gaps for those who haven't got this background. OK, so, about 4.6 million years ago, the Earth was pretty much organised into a sphere and had a temperature of around 1,000 degrees. Note also that all the material forming the planet was randomly spread around. But at that point, three things were happening which caused the planet to heat up further. So, what kind of things would cause the planet to get hotter?
All the impacts from rocks and meteorites and other stuff in space. When that stuff hits the Earth, that impact energy would be converted into heat energy. That would heat it up.
OK, good. Well, sure, that's one of the three main causes of this heating. Certainly at the upper levels, the crust of the planet. Now, what else?
The sun would have heated it?
Well, yes, but I don't just mean warming the surface. We are talking about heating the planet right down to the core, the centre. How did the Earth heat up so that iron, for example, could melt? That's at about 2,000 degrees Celsius.
What about radiation?
Yes, that's it. That is probably the most important cause of the heating up. Radioactive elements, such as uranium, within the rocks inside the planet decayed, and as they did so, heat was generated. In fact, radioactive decay is still going on, but at a slower rate than previously, since, of course, there isn't nearly as much radioactive material left due to this decay over time. OK, a third cause of the heating process was compression due to gravity. As the size of the planet grew due to impacts from space, the gravity increased, and the pressure itself contributed to the heating of the Earth's interior. So, we have three main causes of the heating up of the planet. Now, just to repeat, impacts from the objects outside the planet, radioactive decay of the elements inside, and heating due to pressure caused by gravity. So, over the course of 1 billion years, all these things eventually pushed up the heat until temperatures were hot enough to melt iron and other rocks. Now, as you know, the Earth is composed of a variety of different types of materials, and so these rocks and minerals have different densities. So, that means that heavier, the denser material tends to sink over time, and lighter material tends to rise and float above the heavier stuff. That is what happens in a liquid or molten environment, of course. So iron, in particular, being heavy, sank toward the centre, and lighter rocky material rose toward the surface. At the same time, gases escaped from the molten rocks and came out at the surface, allowing an atmosphere and oceans to form. When all this sinking and rising, this reshuffling process eventually slowed down over time with the gradual cooling of the planet, what we find is a stratified Earth. In other words, a series of layers, with the crust, that is, the part we live on, being the lightest, then further down the mantle, then the outer core, and finally, at the centre, the inner core. So, this process, called differentiation, led to the change in the arrangement of the interior structuring of the planet and the formation of the atmosphere and the oceans. So, while originally all material was homogeneous, randomly mixed around the planet, eventually we get a planet divided into different layers. This differentiation has been called perhaps the single most important event in the history of the Earth.
Now get ready to answer the questions. You may use your notes to help you answer. 25. What is the main topic of the lecture? (26) Why does the professor say this?
As with many theories in science, it's pretty much open to revision.
27. What does the professor imply about the formation of the Earth? (28) According to the professor, how was rock distributed before differentiation? 29. According to the professor, which is probably the main reason for the heating of the Earth? 30. What 2 points are true according to the lecture?